Hello, everyone. My name is Zach, and this is Hudson Public Library's Science Explosion. So, thank you so much for joining me today. I've got a fun little activity for you. All right, so we're going to be talking about atoms and the things that make up atoms. So, I've got to start off with a joke here. So, why should you not trust an atom? Because they make up everything. All right, so if you don't get that joke, don't worry. Or if you think it's too corny, don't worry, that's fine too. All right, so if you want to follow along with this, then you're going to need a couple things. The first thing is you're going to need one of these sheets right here. So it's got something for you to work with a little model of an atom. It's got the atom, a place for a name, and then you can write the number of protons, neutrons, and electrons right there. And if you want one of these, they are linked in the description where you can download them and you can print as many of them as you like. And there'll be a little bit more details of where I got that from in the description as well, if you want to follow along, which I would say would be a great idea. All right, so this is all about eating these, and what you're going to be eating is you'll just need to pick a few things that you would like to act as your protons, your neutrons, and your electrons. So I have picked mini marshmallows and chocolate to act as mine. So let's get started on this. So what is an atom? Let's start with that. So my joke earlier about atoms making up everything. So that's because all matter is, so all this stuff, so this, me, what, you, whatever, it's made up of atoms of different types of things. So what is an atom? Well, really simply put, an atom is the smallest that you can get in something while it still is that thing. All right, so think about, let's see, think about a paper clip. Now, we'll just say that it's made of iron. I know it's made of stainless steel. Let's pretend it's just made of iron. So that paper clip is made of iron. And if you get really, really small, it's made up of molecules. But even smaller than that, it's going to be made up of atoms. And so it's going to be made up a bunch of atoms of iron. Now, you can get smaller than an atom, but if you get smaller than an atom, then it's not iron anymore. It's just what it's made up of. So, an atom of iron is iron. An atom of gold is gold. But atoms are made up of things that are smaller than that. And let's say an electron of iron is just an electron. It's not an electron of iron. All right, so that might not make quite sense, but just think about it like these Legos here. All right, so this isn't a perfect analogy, but I think it works well enough. So so I've got two different Lego pieces right here. This is a 2x4 and this is a 2x3. So atoms are made up of things called protons, neutrons, and electrons. And if they have a different number of protons, neutrons, and electrons, then it's a different thing. So let's say this is an atom of 2x4, and this is an atom of 2x3. Now, I'm calling them those names because that's what their names are. But if this had two more little studs on it, then it would be a 2x4. But that makes it a different thing. So think about it like iron is actually just the name that we call something having that many protons, neutrons, and electrons. So that's a really simple way to think about it. You should think about what these things are as their number of their particles in them. So if you were to add two more to this, it wouldn't be a 2x3 anymore. It'd be something completely different. Now we're going to start on this diagram with the simplest of all elements, the 1. And you see I've got a little 1 here. And I think this one is even more appropriate to be hydrogen because it's shaped a little bit differently and it's kind of hollow. So you'll see why that makes sense. So Don't worry, we're not going to do all of them. That would take so long. But we'll talk about a couple different ones. So if you want to take this, get your foods ready here. You might be wondering what all these circles are for, but don't worry, I'm going to help you figure that out too. All right, so hydrogen is the number one. So hydrogen has 1 electron, 1 proton, and 0 neutrons. It doesn't have neutrons because it is so simple, it doesn't even have those. So the protons and neutrons for this kind of model, don't worry, I'm going to talk about that later, anybody who's a stickler for these, they live right in the middle here. So this is going to be the core, and the protons and the neutrons are in a core. So protons have a positive charge, think P for proton and P for positive, and neutrons are neutral, so neutral, neutron. And the electrons live out here in these orbits, and they are negative. So it's a 1 for a proton right here in the middle. Boop. And I'll use a chocolate chip for this one. It's a 1 here. Let's see if I can tip it. Whoop! I'm going to have to hold it. So right there, boop, there's a 1 proton and there's a 1 electron, but there's no neutrons in that core. All right, so, whoo, that was weird. All right, so when you're making these little models, you're going to want to fill up the rings that are closest to the center first. And these different rings have different numbers of electrons that they can hold. The first one only holds 2. It's kind of weird. All right, so that was that first one. So if you want, you can eat those. So you can see right here, there's the shell. I got 1 proton and 1 electron right there. So I'm working off of a book that we've got from the library here, the Elements book. We've got a few like it, but this one is really good because it tells you exactly what's in it. And I think this is a really cool hands-on way of seeing it. So let's talk about another one, because hydrogen's a little too simple, honestly. Hydrogen is very common, by the way. I think it's the most common one. So hydrogen is the lightest of all the elements because there's like nothing in it. And it is used for rocket fuel. There are some engines who make it, and it's a really cool one because when you burn hydrogen, the byproduct is water. So that's honestly really cool. All right, so let's talk about another one. Let's go just a teeny tiny bit more complicated, but not by much. We're gonna go with number 2. So number 2 is helium, and helium is the second element, and it's got 2 of this in here. So it has 2 of everything. So we're gonna give it 2 protons right here, put them right in the middle, 2 neutrons, remember those also go in the middle, so you can see right here, putting all 4 of those whoop, in the middle here, and then it's got 2 electrons. So boop and boop. I'm gonna bring that up above so that you can see what that looks like. Perfect. Sorry, I don't know how the sound is gonna be on that when I move that. Probably not super pleasant. Here we go. I'll move it over there so you can kind of see it. All right, so helium is number 2, and it's where you start to get neutrons in this as well. So you've got, and you can do whatever ones of these you want. I'd recommend practicing building these models because it helps you think about them. All right, so that's filling up this first level, this first energy level of where the electrons are. But once you get more complicated than this, now you start to jump more. So I'm going to jump way to a different number. I'm going to jump all the way to number 6. Now, why am I jumping to number 6? Number 6 is carbon. And carbon, although you might not talk about carbon a lot, it's probably the most important one in your life. So, why do I say that? Well, it's arguable because there's a lot that's really important. You know, you can't breathe without oxygen. That's pretty important. The atmosphere is mostly nitrogen. But you know what you are? You're mostly carbon. So you are mostly carbon, also water. So a lot of hydrogen and a lot of oxygen. But I'm going to say carbon because we are what is called carbon-based life forms. So when you think about carbon, you probably think things like pencil lead, which is not made of lead, it is made of carbon, or diamonds, or oil. There's a lot. By the way, oil is made of carbon because living things are made of carbon, and oil used to be living things. Same thing with coal, actually. All right, so we're going to build number 6. So carbon has 6 protons, 6 neutrons, and 6 electrons. So we're going to keep building out from here. So we've got 1, 2, 3, 4, 5, 6 protons. 1, 2, 3, 4, 5, 6 neutrons. And then there's going to be 2 in this first red ring here, because that's what we already filled up when we made hydrogen, or excuse me, helium. And then we're going to fill up part of the next one. So this next one, we are not going to completely fill that one up either. This is going to be, so I've got 2 there, so I need 4 more. Well, I almost poured just the right amount. So not filling up this anymore in this first ring because we already filled that one up. So 1, 2, 3, 4. Now, a lot of times when people are making these diagrams, they'll put them right into close places like this so that they're easier to count and see. So I'll do that for you too. So I'm going to move this over here so you can see it. So that is what we make when we're making carbon. So if you get these types of diagrams, which I would say is really easy, really fun to do, then you can just make any model that you want. Now this one only goes up to 3 levels, but you can draw more after that if you would like, because I would definitely say start with the easier ones. And you're gonna wanna look up these models until you know how many electrons can fit into these different levels. All right, so that is pretty much it for this part of that. Now, I wanted to take a little bit of time to let you know this is a way of thinking about these things, because this for a long time was the model of how atoms were laid out. Basically, sort of like you think of the inner part of being like the sun, and then it rotates around like planets. Well, it's a lot more complicated than that, but this is a good way of thinking about it. So don't think that this is how it actually is, that electrons are just these little particles that go around, because I have to let you know, electrons, instead of being like a little chocolate chip like this, I think it's actually a lot more helpful if you think about it like a cloud of cotton candy. So if you happen to have some cotton candy, you could say, take one piece of it and then stretch it around. And it's not just that it necessarily is in these energy levels, that's where it's the most likely to be at any given time. It's a little bit more complicated, and we're talking about quantum mechanics and quantum physics at this point. But that's okay. So just know it's not one solid particle when you're talking about what electrons are. They tend to be a lot more like clouds, almost like a vapor, but they can also act like particles. The important thing to consider when you're talking about this or anything else in quantum physics is that when you measure something, you change the way it acts. So when you measure an electron, you actually make it act more like a particle than a wave. So I know that's a little bit complicated, so I'm not going to talk too much about it, but just keep in mind, this is a useful model, but electrons don't just orbit around the center of the thing like planets. All right, so It used to be that oh, and so molecules. I should talk a little bit about what a molecule is. So a molecule is when atoms combine together and they make something more complex. So the easiest one I think to talk about, because it's so common, is water. So water is made up of hydrogen and oxygen. So 2 hydrogens plus 1 oxygen equals water. So hydrogen is a gas at room temperature and so is oxygen, but when you put them together, they make a liquid at room temperature, and that is water. So something completely different. So that's why I say an atom is the smallest amount of something that's still that thing, that element. But a molecule is the smallest amount of something that is that substance itself, not just the element. So you can't get any smaller than a molecule and still have water. Water, you can't have an atom of water. There's no such thing. It's just a molecule of water. So think about it like, let's see. I know it's not the right numbers, but remember these little Lego pieces are atoms. And let's say water is, I know this is obviously not hydrogen and oxygen here, but water is 2 of these and 1 of these. So this is what a molecule of water is. Again, not the right number on here. I could have probably just grabbed it, so it would be the right number, but oh well. So 2 of these combine, and this is what a water molecule looks like. Or let's call it a substantaneum molecule, because that's clearly not what it actually is. But let's say our substantaneum molecule, this is what it has to look like when these 2 things combine. So if it was taking away this, now it's not my substantaneum anymore. Just like if you were to take away 1 water or 1 of the hydrogens from water, then you wouldn't have that. Or if you were to add an oxygen to the H2O, you would get H2O2, and that is actually something completely different. And that's something we've used in science explosions before. Do you know what it is? I'll let you figure that out. All right, so now you've heard me talk about how an atom is the smallest, so a molecule is the smallest thing of that substance. An atom is the smallest that you can get in any element. But there's smaller things than that. We know that there's protons, neutrons, and electrons, but can you break those apart? The answer to that is yes, very much so. So we didn't know about those until, I would say, pretty recently. So you might not even end up talking about these much in school. I know that we didn't when I was a kid, but you can definitely break these apart too. And that's where you get weird. So when you think about physics, if you understand the math, physics isn't too hard to understand on what's called a macro level. So that means big things. So I throw this in the air, what will happen? It'll come back down. Woo, oh man, that was a rough hypothesis to make. I wasn't sure if it'd follow through. Obviously not. I know I throw this, it's gonna come back down. Unless something else stops it from falling, like somebody else grabs it or whatever, it's gonna come back down because I know that's how gravity works. Well, things are a lot more complicated the smaller you get. So if you wanna break apart, let's see, which one did I say? Yes, this is a proton. What happens when you break apart a proton? Well, you get something even smaller, and you get something called quarks. All right, so there are different quarks, but when you're building protons and you're building electrons, the important ones you're going to need to remember is the ups and the down quarks. So they are, let's see if I remember right. Yep, 2 up quarks and 1 down quark in a proton. And it's going to be the opposite in an electron, 2 downs and 1 up. All right, so think about quarks as the building blocks that build the building blocks that build the building blocks that build you. It's just getting smaller and smaller. But what else are there? So there's up, down, top, bottom, and then my 2 favorite quarks, because the names are so weird. And by the way, this is Q-U-A-R-K. There's charm and strange. Now, whoever named those two, congratulations. I don't know why, but those are just great names. But that's not the only things that are even smaller than that. You've also got leptons. So, or excuse me, I believe when I was talking about the down, down, up, I believe that's a neutron. So down, down, up is a neutron, up, up, down is a proton. So in leptons, the most common one you're going to know is going to be an electron there. All right, and these are all going to be what's considered a fermion. So fermion is just regular matter. So that's just a way to say that it's a normal matter. But all right, so what do we have here? We've got the quarks, so it's up, down, top, bottom, strange, and charm. But then there's leptons. The most common one of those is an electron. So an electron is a lepton. But then you've also got neutrinos, which could be electron neutrinos, muon neutrinos, tau neutrinos, and then there's muons and taus. These are kind of strange. And then you've also got the really strange ones. You've got the gluon, the photons, the Z boson, the W boson, and then the one that the news liked to talk about for quite a while, the Higgs boson. All right, so I'm not going to talk about those, and that might seem a little overwhelming to just give you all those names. But just know there is a lot more to it than just looking at a model of an atom or even a molecule. So a molecule is something really complex and beautiful, but you can break it up into atoms. And you can break up an atom into smaller things like we've got here. But then it's even cool to know that even this teeny little proton, you can break down into 2 up quarks and a down quark. So, alrighty, that's just some food for thought in there. If you want, we've got this book and a few different like it. So this is Elements, a visual encyclopedia of the periodic table. And it's a Smithsonian book. We've got this one and a few others that are like it here at the library. All right, so thank you so much, everyone, for joining me. My name is Zach, and this is Hudson Public Library's Science Explosion. Thank you so much. Bye.